Hey, you survived the very first video. This one's going to be much shorter. So, for Unit 1, Part 2, we're going to talk about how to actually physically separate mixtures. In the previous lesson, we talked about how there are two main categories in matter: pure substances and mixtures. Remember, a pure substance, specifically a compound, those elements cannot be separated physically. But mixtures can be. Mixture, remember, is two or more pure substances physically combined. They're just mixed together. And so we can, since they're physically combined, we can physically separate them. So here are just a few different ways to physically separate a mixture. The first one is called filtration. Basically, let's pretend we have something in water, not dissolved in water, but we have like dirt in water. We have rocks in water. The example we're going to see is there's chalk in water, and we want to separate the chalk from the water. So what you do is you take that water that has chalk in it and you pour it into what's called a funnel. Actually, I'm going to do the illustration down here. You're going to pour it into a funnel which usually has filter paper on top. What happens is the water can soak right through the filter paper and go down the funnel and end up in this flask. So in the flask is only the water, nothing else, it's just the water. The chalk in this case, since it cannot go through the filter paper, it stays up top in the funnel, and then when you take out the filter paper and let it dry, all the chalk will be on the filter paper and all the water will be in the flask. So you physically separated this mixture. And this, in this case, since it's a suspension, it's what kind of mixture? A suspension. That's right, it's a heterogeneous mixture. Heterogeneous mixture are suspensions. And colloids. Another way to do a filtration is called shifting or sifting. That's right, sifting or sieving. Sifting or sieving. Basically, what happens is you take a bunch of solids and you put them on this. It's called a sieve. It's a grate with little tiny holes, and you put all of it on top of here, and you start shaking it. You just shake it back and forth. All the tiny particles fit through these tiny holes and end up in the bottom in another container. Anything that's too big to fit through these holes ends up on top, and then you can just dump that out. And then what you can do next is get another sieve that has even tinier holes, and then you can sift or sieve through the rest of this. And you can keep doing that and doing that and doing it to get rid of bigger particles to end up with smaller and smaller particles. So that's one way, again, to filtrate something. In this case, this is for two different solids. So you want to use a sifting or sieving technique to separate two different solids that are different sizes. If you have a solid that's inside a liquid, you can do the filter paper, pour it into a funnel, and into a flask technique. So again, those are two different kinds of filtrations. Another way to physically remove some mixtures is by magnetism. So in this example here, we have sulfur and we have iron fillings. Sulfur and iron are both elements, and we're going to physically combine them. So remember, even though it's two different elements, this is not a compound because they are not chemically combined. They are physically combined. That makes it a mixture. So if I mix sulfur and iron together, how can I get all the iron out of the sulfur? Easy. Iron is magnetic, sulfur is not. So if I bring a magnet near this, all the iron will go on the magnet, and then the sulfur will be left over in the dish. So we have filtration, we have magnetism. Another way to separate some mixtures is flotation. Some things float, some things don't. So if I give you, I'm just throwing this out here, if I give you a bag full of rocks and plastic beads, now you could probably individually go through each one, hand do it, that might take a while. A very much faster way of doing this is to take that bag of rocks and plastic beads and dump it in a glass of water, or in science we say a beaker of water. the plastic beads will float to the top and the rocks will sink to the bottom. That's an easy, fast way to separate that mixture. The last way is solubility. So let's say I have a bunch of sugar or salt, doesn't matter, mixed in with a bunch of sand. Now that one you're definitely not going to be able to take, individually and pick each one apart. Just not going to happen. So what can you do? Well, dump it in water, just like the flotation. Here's what happens. The salt or sugar will dissolve in the water. The sand will not. The sand will settle in the bottom because sand does not dissolve in water, but sugar and salt will. Then you can take that, pour it into filtration. So again, all the sand ends up on the filter paper and all the sugar or salt water ends up in the flask. Okay, I got rid of the sand, but then how do I get rid of the sugar or the salt? Well, there's another thing you can do. You can boil it. So this is salt for this example, because salt has a different boiling temperature than water, if you boil water, the water evaporates before the salt does, because salt has a very, very high boiling point. So if you heat up salt water, what happens is all the water will evaporate and the salt will be left over inside the beaker. So those are just some ways to physically separate mixtures. Again, filtration, magnetism, flotation, solubility. I don't think this technically counts as solubility, but we can just say boiling. So there you go.